Welcome to the Before You Begin video for our Swift Fundamentals live lessons. Now, the examples we'll be presenting over the next many lessons are based on the code from our book, Swift for Programmers, which you can learn more about at the URL that you see here. The book is not required for working with the videos, but many people find it handy to have alongside as a reference. As you work your way through these live lessons videos, one of the things that's really important to keep in mind is that Swift is very new and changing rapidly. And for that reason, we'll be posting any updates that are necessary to the Swift for Programmers book website, ditel.com/books/SwiftFP, where FP stands for Programmers. Now, the original book on which these videos are based, Swift for Programmers, was written using Xcode 6.0 and 6.1, as well as Swift 1.0 and 1.1. At the time these videos were recorded, Xcode 6.3 had just been released, and that new release includes an updated version of Swift 1.2. And Swift 1.2 has some breaking changes in it. Now, as I present to you the source code, one of the things I'll do is show you the updated source code, but talk about how things changed as well. In the remainder of this Before You Begin video, I'll talk about how to get the software that you need for working with the examples, how to get the code examples themselves so that you can simply load them up into Xcode and work with them directly rather than entering them from scratch, though I will actually recommend that you enter them from scratch because it helps you learn the programming language a lot faster. I'll also talk about Xcode's playgrounds and project capabilities. As you'll see, we provide code examples in two different forms. One is a new feature of Xcode 6 called a playground that executes your Swift code for you as you enter it. And then another is the concept of a project, which is the more traditional way of building a larger application. And we'll use projects for any cases where we have multiple source files that we need to work together. Finally, I'll talk about how you can contact me for help directly if you have any questions as you're working your way through the videos. Throughout these live lessons videos, I'll be presenting Swift to you in the context of Apple's Xcode 6 integrated development environment. Now, this is the IDE that you would use for developing OS X desktop apps as well as iOS mobile apps. Now, the most recent release of Xcode is always available to you for free from the Mac App Store, which you can access through an icon on the dock at the bottom of your screen, or, as I'll show you in a moment, they also provide a current link on the web page developer.apple.com/Xcode. Now, at the time of this recording, the most recent version of Xcode is 6.3, and it absolutely requires OS X Yosemite to run. So if you don't have OS X Yosemite, you'll either need to upgrade to it in order to download and install Xcode 6.3, or if you'd like to work with these videos in the context of Xcode 6.2 or an earlier version of Xcode 6, then you'll have to download those separately. So I'll talk about that again in just a moment. Now, as Xcode evolves, there will be pre-releases available to you as well, and those also can be accessed through the same URL. So let's go over to my web browser for a moment. And here you can see I've already preloaded the developer.apple.com/Xcode URL. Now, you can get an overview of the integrated development environment here, but most importantly is the Downloads tab. And if I scroll down a bit, you can see Download Xcode for free, the current version, which at the time of the recording again is 6.3, and they provide a link for viewing the app directly in the Mac App Store. So you can click that link to go to the store and install Xcode onto your system. Now, again, if there's any reason whatsoever that you cannot upgrade to OS X Yosemite, you could still work your way through these live lessons videos using Xcode 6.2, which you can download through the additional tools section here by clicking View Downloads, and when you get to the downloads you'll have to locate it, but here is the link to get Xcode 6.2. Now, the one caveat is if you work with anything prior to 6.3 with these videos, there will be some Swift features that I talk about or show you that are not available in earlier versions of Xcode because they are new to Swift 1.2. Now, as far as Swift is concerned, there's also a web page dedicated to Swift, developer.apple.com/Swift. So let me go back over to my browser, and you can see the web page already loaded here. There's an overview of the language itself. There is a blog where you can learn about various features of Swift and where they'll typically introduce new features as they are brought into the language. And then separately, there's a very nice resources page which gives you access, among other things, to books about Swift that are written by Apple, various code samples, and various videos as well where you can learn more about the language. Now, keep in mind with the videos that these particular ones that you're seeing on the screen at the moment were recorded at the WWDC 2014 conference, and for that reason they don't have any of the new features that were introduced in Swift 1.0, 1.1, and 1.2. That was a beta pre-release version of Xcode that was presented back at the conference. The books, however, have been updated with all of the latest language features. As I mentioned earlier, the examples that I'll be presenting throughout these live lessons videos are from our corresponding book, Swift for Programmers. And you can get those examples from the URL that you see here on the screen, ditel.com/books/SwiftFP, which stands for programmers. So let me go ahead over to a web browser for a moment and pull up that web page. And once you get to the web page, you can scroll down and you'll see the link here in the left side to the code examples. Once you click the link, a zip file will download onto your system, and once you extract that zip file, you'll find within it a bunch of chapter folders that represent the corresponding lessons. So chapter 2's examples are going to be presented in lesson 2 of these live lessons videos, and correspondingly for the subsequent chapter folders as well. Now, throughout the examples folders, you'll find that there are a combination of playground files and projects. Playgrounds are a new feature that was added to Xcode 6, and they specifically enable you to write Swift code and see the results of that code as you write it. So the playgrounds basically interpret the code as you write it, and you'll either get errors or you'll get results. And so it's a really nice way to interactively learn the Swift programming language. For many of the examples throughout these live lessons videos, we will simply provide a playground. However, once we get into some of the more complex apps that have several different source files associated with them, in that case we will create an Xcode project instead that contains all of the different Swift source code files that we need. For every single example, the first line comment in the file will tell you the name of the playground file or project so that you can go and locate it in the lesson folders and be able to open up the correct one for following along in the videos. As you work your way through these Swift Fundamentals live lessons videos, if you have any questions at all, please feel free to email me directly at paul.ditel@ditel.com. And you can also reach me on our Facebook page, facebook.com/DitelFan, our Google Plus page, google.com/+DitelFan, and finally on Twitter @Ditel. You're now ready to begin the Swift Fundamentals live lessons videos. Welcome to Lesson 1, Introduction to Swift and Xcode 6. In this lesson, I'll begin with some slides in which I'll discuss some of Swift's key language features, some of the error prevention features that are built into Swift, the various libraries that you can use when developing in Swift for both iOS and OS X, and then I'll overview some of the resources that Apple provides for learning Swift programming. Towards the end of this lesson, I will then show you how to create Swift apps using Xcode 6, And as you'll see throughout these live lessons videos, sometimes we use what are known as playgrounds, and sometimes we use what are known as projects. A playground is interesting because it enables you to see the code execute as you write the code, which makes it a great way to learn Swift and to test out features, not just in the Swift programming language, but even features of the various iOS and OS X frameworks that you'll use when you're developing apps for those platforms. And then separately, we will typically use a project when we have multi-source file programs so that we can organize all of the files into a single project. So we'll demonstrate how to create a basic playground and how to create a basic project as well. And then you'll use those features as you proceed through lessons 2 and beyond. In this video, we're going to take a look at the key features of the Swift programming language. Now, one of the things that you'll want to keep in mind as you watch these live lessons videos is that Swift is really brand new, and as such, it's rapidly evolving, and there can be changes along the way. In fact, I'm recording these videos just after Xcode 6.3 was released, and in Xcode 6.3 is a new version of Swift, version 1.2, which has breaking changes from prior versions of Swift. So if in fact you're working your way through these videos and you run into a compilation error and you're using a version of Xcode and Swift that is subsequent to the one I'm using in these videos, feel free to just drop me an email and I'll help you resolve that problem rapidly. Now, the Swift programming language was designed for performance. When they introduced Swift at the WWDC conference in June of 2014, they had benchmarks in which they saw a 1.5 times increase in speed for the various testing that they were doing. And of course, this will hopefully also improve over time as they improve the language itself and the compiler as well. Now, the language was designed specifically to be interoperable with Objective-C. Objective-C has been the primary development language for OS X desktop development and for iOS app development since their inception, and for that reason there are millions upon millions of lines of Objective-C code that are already out there. So as you begin working with Swift, you don't necessarily need to rewrite the apps that you've already built for OS X or for iOS. In fact, what you can do is incorporate new capabilities written in Swift and simply use your existing Objective-C code. And in fact, you'll be doing that constantly by reusing the libraries of the Cocoa framework for desktop development and the Cocoa Touch framework for iOS development. Now, you'll see that there are lots of different language features available to you in Swift, and they've been chosen from various popular programming languages, both compiled languages and scripting languages alike. So what I'd like to do now is to provide a brief overview of some of these key language features that have been incorporated into Swift. Now, one of the key design goals of the language itself was to make the language simpler to use than Objective-C. And one of the key features for that purpose is type inference. With type inference, you can determine the type of a variable or the type of a constant based on the value that's assigned to the variable or used to initialize the constant. Not only that, you'll see other scenarios throughout Swift in which type inference can be used as well. So for example, if you have a variable that is of an enumeration type, you can assign a constant from that enumeration type to the variable without qualifying the constant's name with the type name. And the reason for that is that Swift already knows the type that the constant has to come from based on the type of the variable. For those of you who are familiar with C-based programming languages like C, C++, C#, Java, and even Objective-C as well, you're going to recognize a lot of the syntax in the Swift programming language. In particular, you'll be familiar with the switch multiple selection statement. Now, in most C-based languages, that statement is capable of only testing constant integral expressions, and every individual case in the switch is capable of matching up with one specific value. And in some programming languages, you're also able to use strings for the cases as well. Now in Swift, you can use any type that you'd like. Not only that, each of the cases can test an individual value, but are more flexible than that. You can test sets of values, ranges of values. You can even use where clauses that enable you to specify Boolean conditions that must be satisfied for a match. Unlike most C-based languages, Swift also provides a concept called a tuple, which is just a collection of values. That collection of values may have values of the same types or of different types and can be of any length as well. Now, the Swift language has built into it capabilities for doing what we call composing a tuple, which is where you create a collection of values, and also for decomposing a tuple, which is where you extract values from the collection. Many of today's scripting languages, and even some of the compiled programming languages as well, provide capabilities for what's known as functional programming. And the key concept for implementing functional programs is the concept of a closure, which is also sometimes called a lambda expression in some programming languages. Now, closures are basically anonymous functions that not only can you call to perform tasks, you can assign them to variables to treat them as data, and you can also pass them into other functions or methods and return them from other functions or methods as well. And in fact, there are lots of contexts in which you will use closures in the Swift programming language. So for example, there's a global function named sort that can be used, for example, to sort an array of elements, and the sort function receives as one of its parameters a closure that helps the sort function determine sorting order. So that's just one case. As you'll also see when you work with the Cocoa and Cocoa Touch frameworks, there are many methods of the classes within those frameworks that expect as their arguments what are known as blocks in Objective-C, and Swift's closures can automatically be bridged to Objective-C blocks, and bridging is a concept that's built into the Swift runtime that helps Swift programs interact with Objective-C code, both passing Swift data into Objective-C code and receiving Objective-C data back into Swift code as well. Next, we have Swift's concept called optionals. Now, optionals are a way of expressing the fact that a given object may have a value at some point and may not have a value at another point. So this is similar in concept, for example, in C-based languages like C and C++, to having a pointer that's either pointing to something in memory or is null, or in the Objective-C language, having a pointer that is either pointing to something or is nil, N-I-L, or in languages like C# and Java, having a reference that refers to an object in memory or is null. Now, optionals are interesting in Swift because they can be used with any type. As you'll soon learn, Swift has both classes as well as structures and another concept called enumerations. Class types are reference types, structure and enumeration types are what we call value types, and any of those types can be used with optionals to say that a value of that type may or may not have a value at a given time. And this also replaces a lot of the error handling types of capabilities that you'll encounter in many of today's C-based object-oriented languages. Swift does not have a try-catch mechanism for exception handling. Instead, you'll often use optionals where you call a method, and if you get back an optional that is nil, that might indicate that a problem occurred, and if you get back an optional that actually contains a value, then you know that you succeeded. And there are language features that are built in to enable you to quote-unquote unwrap those optional values so that you can then use them in your code. Next up, we have the concept of dictionaries in Swift. Now, as in typical programming languages today, most languages have a built-in array type that you can use for manipulating arrays of values. In Swift, the array type, the dictionary type, and also the new set type that was just introduced with Xcode 6.3 and Swift 1.2 are all built into the Swift standard library. And of course, there is also syntax built into the language itself for working with these collection types. Now, the dictionary type in particular is built into the Swift standard library to support manipulation of key value pairs, and the new set type has been added for manipulating sets of data as well. In addition, string, array, and dictionary, as well as the new set type, are all value types. And what that means is that they are going to be manipulated throughout your Swift code by value. That means anytime you assign a string, an array, a dictionary, or a set to a variable, a copy of that object is being made. Anytime you pass those into functions, copies of them will be made. Anytime you return them from functions or methods as well, copies of them will be made. Now, that may sound like a tremendous amount of overhead, especially if you're dealing with very large data structures. However, Swift has built-in optimizations such that those copy operations are performed only if necessary. A capability built in called copy on write helps with that. So for example, if you assign a large array to another variable in your program, initially that other variable and the original array variable are both really referring to the same array object in memory, but as soon as you attempt to modify any element of that array via either of the two variables, then the copy gets made so that the two variables act as if they were separate copies in the first place. We continue our discussion of the key language features with Swift's structs and enums. Now, it turns out that Swift supports both value types and reference types. Value types that are copied when you assign values, pass values into methods, return values from methods, and reference types that, as their name implies, when you pass them around or assign them, you are assigning references, which are in effect like pointers underneath the hood. They refer to an object elsewhere in memory. Now, when you're working in the context of Swift, you're going to have to decide whether each new type you create needs to be a class, a struct, or an enum. So for example, if you have a fixed set of values, you know those values in advance, and you would typically define such a concept as an enum. On the other hand, if you want something to be a value type that's copied by default, then you would typically define it as a struct if in fact you know that there are a set of values for which you don't know all the values in advance. So for example, if you were creating a point data type that represents an XY location on the screen, you're not going to enumerate every single XY location in an enum. Instead, you can define such a concept as a struct. Now, classes are often going to be required, especially when you're writing code using the Cocoa or Cocoa Touch frameworks. For example, if you're creating a new user interface component, you're going to have to inherit from an existing class in the Cocoa or Cocoa Touch frameworks. And one of the key differences between classes and the value types is that classes support inheritance, whereas structs and enums do not. So as we work our way through these live lessons videos, we will talk about all of the key details of classes, structs, and enums, and we'll fill in some of the missing pieces on when and why you would choose to use those various capabilities. Earlier in this video, I mentioned the concept of tuples that allow you to gather together a bunch of values into a collection. One of the great features that you can implement in Swift using tuples are the concept of functions that have multiple return values. In most programming languages, especially the C-based compiled programming languages, you can only return one value at a time from a given function or method. But by returning a tuple, you can specify as many return values as you want, and not only that, by using the language features that are built in for working with tuples, you can then immediately extract those individual return values from the tuple so that you can use them in your calling code. Like many of today's popular programming languages, Swift also supports the concept of generics, which enables us to write code once for tasks that are going to be performed on various different data types, but where the logic is identical. So for example, built into the Swift standard library, we have various collections like array, dictionary, and set, and each of these is a generic type, because an array, for example, can store whatever type you want it to. So you say you want an array of strings, and Swift enables you via the generic array type to create an array of strings. If you would like an array of employees instead, you specify that at the time that you create your array, and Swift will then ensure that that array only is able to store employee objects, and any time that you try to grab a value out of that array, it will give you back your employee objects. So generics are a very nice way to simplify your code because you can write that code once for all types generically instead of writing separate cases for every individual type you wish to process. Swift also supports operator overloading. So basically what this enables me to do is redefine how a given operator works for my own new type. So for example, there is no built-in complex number type in Swift, so if I wanted to, I could create my own complex number type and then enable objects of that type to be used in arithmetic expressions by overloading the arithmetic operators. So I could redefine how the plus operator works for complex numbers, and the minus operator, and the times operator, etc., and then I'll be able to write expressions like a plus b, where a and b are complex numbers as opposed to simple things like integers. Now, Swift is interesting in that it has full support for Unicode. Not only can you overload most of the built-in operators, you can also create entirely new operator symbols by following the rules of the language. Now, there are certain regular operator symbols that you can use to create new symbols. In addition, there are a wide range of Unicode characters that you can use to create new symbols as well. And we'll demonstrate not only creating overloaded operators for existing operators in a later lesson, we will also demonstrate creating an entirely new operator from scratch. Another nice feature built into Swift is the concept of string interpolation. What this enables you to do is to compose string contents by inserting the values of variables and expressions into a string literal and enabling Swift to figure out the values of those variables or expressions and construct an appropriate string based on the contents. Finally, we have the concept of nested functions. Within the curly braces that define the body of a given function, you can nest other function definitions that are callable only within the outer function's body, unless you return them from that function so that they can be called in another scope. And this same concept can also be used in the context of methods, where a method is simply a function that is defined inside of a type. So Swift actually supports both global functions, which are sometimes referred to as free functions, as well as functions that are built into given types, and those we call methods. In addition to all of the language features we've discussed so far, there are also a bunch of error prevention features that are built into Swift. For example, curly braces are required for every single control statement's body. That way you always have the body. You cannot accidentally forget to wrap the body in curly braces and then add statements later on that are not technically in the body of the control statement. Also, Swift does not have pointers, so you cannot directly access memory addresses in Swift the way that you can in some programming languages such as C, C++, and Objective-C. The assignment operator, which often gets confused with the double equal sign Boolean equality comparison operator, either by beginning programmers or by experienced programmers who just have a typo, does not return a value. And because of that, it's not possible to accidentally put a single equal sign in the condition, for example, of an if statement when you meant to do a double equal sign for a Boolean comparison. Semicolons in Swift are completely optional with one exception, which is that if you want to have multiple statements on one line of code, they must be separated by semicolons. In addition, parentheses around conditions in control statements are optional, and that also has the effect of making your code a little bit easier to read. Other error prevention features include the fact that variables and constants must have values. You cannot try to use a variable or constant in your code before it has been initialized, and that means it's not actually possible to get to execution time in Swift with garbage data inside a variable or a constant. Also, integer calculations are checked for overflow by default, which means, for example, if I were adding together two very large integers and the sum results in a value that cannot be represented for the particular integer type, that's going to be an overflow error, and at runtime the program will fail in that case. There are no implicit conversions either, so that means that even something as simple as adding together an integer and a floating point number cannot be done implicitly in Swift, because there would have to be a conversion of the integer value to a floating point value, which is the typical way that would happen in other programming languages. In Swift, if you want to add two numbers together, they must both be of the same type, and that means you must use explicit conversions to specify your intentions in Swift. Also, array indices, or subscripts if you will, are bounds checked at execution time. So anytime you access an element of an array, it's going to make sure that the index number is within the bounds of the array, starting with an index of 0 up to one less than the actual length of the array. And also, Swift uses automatic memory management. So there is a concept called ARC, automatic reference counting, that helps determine when there are no more references to a given object in memory, at which point that object's memory is automatically reclaimed for you. Now, in addition to all of those language features and error prevention features, there are also extensive libraries for you to work with. So throughout these live lessons videos, we'll be talking a lot about the Swift standard library. The Swift standard library not only has the data structure types, it also contains various so-called protocol types. Protocols are similar to interfaces in some other programming languages. In addition, you have direct access to the Cocoa and Cocoa Touch frameworks, which as of right now are primarily written in Objective-C, but Apple has stated that future libraries will be written in Swift. And then finally, Xcode 6 helps you in terms of accessing Cocoa and Cocoa Touch frameworks and other Objective-C code as well by exposing Objective-C APIs to your Swift code in a format that is Swift compatible, if you will. So for example, when you're invoking a method on an Objective-C class, when the window pops open in the IDE that helps you do code completion, it's going to be showing you that method in its Swift syntax, or its Swift equivalent syntax, if you will. The last item I'd like to discuss in this video are the various online resources that are available to you. Now, of course, if you have any questions at all, you can always feel free to email me as well. But the Swift resources at developer.apple.com/swift/resources are particularly useful to anybody who's getting started with the Swift programming language. We have 3 different books that are available from Apple. The Swift programming language has not only a quick overview, a quick tour of the entire language, but it also provides the details of the language as well. The Swift Standard Library Reference provides details for various types and also some global functions, or what they call free functions, that are available to you for use in your Swift code. So things like the array type and the dictionary type, for example, are described by the Standard Library Reference. And in addition, for anybody who's going to use Swift to develop Cocoa or Cocoa Touch apps, that is, apps for the Mac or apps for iOS, is going to want to read the Using Swift with Cocoa and Objective-C book. Not only does the book talk about general interactions with the Cocoa and Cocoa Touch libraries, but also if you have already existing Objective-C code, it talks about how you can integrate your Objective-C code with the new Swift code that you're writing. There are also various videos and sample code on that site that you can learn from. Now, once you get into development with Swift in the context of iOS and OS X, you're going to want to visit the respective developer centers for iOS and Mac respectively. So if I go over to my web browser for a moment, the iOS Developer Center, which is at developer.apple.com/iOS, and which redirects to the URL you see on the screen, has all sorts of resources for learning about iOS development, including the iOS Developer Library, which has the reference documentation, guides for specific types of programming, sample code, etc. And similarly, on the Mac side, if you're doing desktop development, you have similar documentation available to you through the Mac Developer Center, which is at developer.apple.com/Mac, and again, that redirects to the URL that you see on the screen here. In this video, I'm going to begin my introduction to the Xcode IDE that you'll be using to build all of the examples in these Swift Fundamentals Live Lessons videos. Now you can see that I've already opened a Finder window to the Applications folder, which I accessed from the left side here. And at the bottom of the folder you can see my xcode.app file, which is what I can use to launch the IDE. Now in my case, I also dragged that down here onto my dock so that I can access it quickly in the future as well. So I'll go ahead and launch it right from the dock here. And when Xcode opens, it's always going to show you the Welcome to Xcode window unless you uncheck this checkbox at the bottom of the window at this point. If this is the very first time that you're running Xcode, it may also ask you to install additional features that are required for development purposes, and you should go ahead and do that. Also, if it's the first time that you're running Xcode, this area over here on the right side is going to be empty. This is where you'll see the complete list of recent items that you've been working on, and in our case that's typically going to be a playground file or a project file for these live lessons videos. Now, as of right now, it's empty because I went and manually cleared the list so that my window would look like yours when you first bring up Xcode the first time. If you ever do want to clear that, you can simply go to the File menu, Open Recent, and then select the Clear Menu item. That will cause this window area to be emptied, and it will also prevent recent items from showing up in this sub-menu as well. As you begin working on lots of different projects and playground files, they will also show up as a sub-menu here under Open Recent. Now within the Xcode welcome window here, you have several links that you can use. This first one will enable you to create a new playground file, which is what we'll be doing in just a moment. Playgrounds are a really handy feature that's new in Xcode 6 and is specifically for the purpose of writing Swift code that executes immediately as you write it, so that you can do things like test out new features that you want to potentially incorporate into your projects. You can use it for learning purposes, as we will be doing throughout these live lessons videos. You can also use it to do things like develop algorithms and see how those algorithms execute. In fact, playgrounds have interesting graphing capabilities to help you look at your algorithms over time, or if you're developing an animation, look at your animation over time, and other interesting features that you can then, once you have finished writing them, copy and paste into an actual project for use within that project. Also, you have the ability to create a new project from scratch, which is what you would do if you're going to create a new iPhone or iPad app or a Mac desktop app. And finally, you have the option to check out an existing project from a source code management system. And that's something that you would typically do if you're working on a larger team of developers who are all contributing to the same project. Now, at this time, I'm going to go ahead and click the X in the upper left corner here to dismiss this window, so that I can show you creating a new playground directly from the File menu. So as you can see, there are various options here in the new File menu option, one of which is Playground, which is what I'll select here. And when you do that, you are given the capability for naming the new playground file and for selecting the platform that the playground is going to be used for testing. Now, basically what a playground enables you to do is to try out various features of Swift and the Cocoa and Cocoa Touch libraries in a way that doesn't involve creating an entire application first. The playground will execute your Swift code as you write it, and it gives you a really nice handy way for doing things like testing new features that you are considering using within an existing app. Also for doing things like creating an algorithm and making sure it works before you incorporate it into your app. And as you'll see as you get into Playgrounds in more detail, not only can it execute the code that you write, it can also help you analyze that code. So for example, if you're writing some sort of an animation and you want to debug that animation, you can watch how that animation executes over time, and you'll even be given a slider that enables you to move back and forth through the animation's code so that you can see what is going right and what is going wrong, hopefully fix that in the context of the playground, and then eventually incorporate that code into your actual project by copying the code and pasting it into an existing project source code file. So as you can see, you can choose from iOS or OS X, and really for the vast majority of the code that I'll present to you in these live lessons videos, the platform that you select is irrelevant, because all of the output that you're going to see will appear directly in the playground. We're not going to be working with GUI components in the context of playgrounds in these live lessons videos, though I will, towards the end of these live lessons videos, have a couple of lessons that show you a couple of basic iOS apps. When we get to that point, we will be coding in the context of a project, not a playground. So you can select either iOS or OS X for this purpose. And the only difference, by the way, is when you finally do get the playground up on the screen, an import statement that specifies a specific framework that should be imported into the playground. Now, once you go ahead and click Next to say where to save the file, I've already created a folder called Swift Fundamentals. You can create whatever folder you want by hitting New Folder down here. And once you specify the folder where you want to save, go ahead and click Create, and now we have our first playground. Now I'm going to go ahead and expand that window, and you can see some features of the playground here. We've got the editor, which has line numbers displayed at the left. I'll talk about how I got the line numbers and the font size in just a moment. You also have this gray area at the right side where the playground shows you things like the values of variables, or in the case of a loop, how many times that loop executed. And everything that you're seeing is happening live. So if I go ahead and change hello playground to hi there, you can see that it immediately changes what's being displayed in the sidebar. And of course I want a lowercase I, so I'll change it again, and we immediately see the change. Now, as far as the line numbers go, these are available to you through the Xcode Preferences option. Once you go into Preferences, if you click the Text Editing tab here in the center of the Preferences window, you can make sure that line numbers is checked. Also, you can do things like change the default indentation if you would like from the Indentation tab here. And I did change my fonts for the purpose of presentation. I selected the presentation option, which has a much larger font. And you can select from a bunch of predefined sets. So I can go with basic, which has obviously a much smaller font. I can go with midnight, which changes everything to a black background with bright colors in the foreground. I can go to an even larger font if I want to for presentation large. And by the way, there are more options if you click the plus button that you can scroll through as well. So a few of those are not currently being displayed up above here, but once you select one, it will then appear in the list up above. So you can go ahead and customize the fonts, colors, tabs, etc. through the Xcode preferences. Now, I just want to go ahead and add one more statement to the playground so that I can talk about the so-called console output window. So as you can see here at the moment, we have a statement that is creating a variable that has the value hi there, and we'll talk about all of this code in more detail in subsequent lessons. But I'm going to just quickly introduce the println statement, which prints out a line of text followed by a new line character, and I'm going to have it print the value of str. Now, as I complete the statement, it is executing the statement, and what you're seeing over here in the sidebar once again is the value of str. If you want to see the actual console output window to see what println is actually generating, you can go to the View menu, select Assistant Editor, and Show Assistant Editor, at which point it's going to display the console output window. Now, in your case, it's probably going to have this about halfway split on the screen. In my case, I had previously gone and resized it so it showed up with the last size that I had used, but you can use the sizing handles to change the size of the console output area and to change the size of the editor area as well, so the sidebar can be wider or narrower depending on what it is that you're trying to display in the sidebar. And one of the things that's interesting about what you'll see here in the sidebar is that the features that appear and what you're able to view depends on the content that you're dealing with. So here I happen to be looking at a string, so it has a pop open here with its quick look feature that shows me the contents of that string. If I were looking at a statement that performed a loop, I'm going to see other options, for example, graphing the values in that loop. And we will demonstrate some of those capabilities as we work with playgrounds and introduce various Swift features throughout the next many lessons. In the next video, I'll show you how to create a basic console output project, which we'll use anytime that we need to have multiple source code files. For the last video in this lesson, I'm going to demonstrate how to create a project like the ones that you'll use for several of the examples throughout these live lessons videos. In addition, I'll just overview various areas of the main IDE or workspace that shows up when you create a project. Now, if you don't already have Xcode up and running on your computer, you'll want to go ahead and launch it from your Applications folder. And once it launches, again, you'll get the Welcome to Xcode window where you could actually create a new project right from the window here, or you can go to the File menu, select New, and then select Project, which is what I'll do here. Now, you'll notice that you have categories for iOS and OS X. When we get to the last two lessons of these live lessons videos in a subsequent part, we will be building a couple of different iOS applications. However, for the pure Swift part of the book, we'll work within the OS X application category with the concept of a command line tool. And basically what that means is a program that just produces command line output. So we'll select command line tool and click next. As before, you'll be able to give a name. In this case, it's your product name. I'll just call it my project for now. And you also are able to specify an organization name, an organization identifier, and a programming language. So for the programming language, we're going to be selecting Swift. So you want to make sure that's selected. And as far as the organization name and organization identifier are concerned, these are more important for when you are going to submit an actual app to the Mac App Store or to the App Store for iOS for the purpose of distributing your apps worldwide. Now, in our case, we're not going to be doing that here, but let's just assume for a second that we were. We would provide our own organization name, and then the organization identifier is normally the company or organization's domain name in reverse. So for example, our website is ditel.com, therefore we reverse it to com.ditel as our organization identifier. And the combination of the organization identifier and the product name becomes what's known as the bundle identifier. This is filled in for you, and that is a permanent name associated with your app for purposes of identifying it in the App Store. Next, you'll click the Next button and specify where you want to save the project. So I'm going to use my Swift Fundamentals folder once again, and I'm going to click Create to create the project. Now, when you first create the project, what you now see on the screen is called the Workspace window, and it brings up the project settings by default. This information is important when you start building real apps, and for example, in our iOS 8 App Development Fundamentals live lessons videos, we frequently go into the project settings to configure various aspects of our projects. Here, however, all we really care about is main.swift, which is the starting point for a Swift application. And it must be named main.swift, by the way. Now, interestingly, you'll notice if you're familiar with other C-based programming languages that there is no main function or main method in this source code file. We have an import declaration, which we'll talk about in subsequent videos, and we have a println function call that's simply going to output the results hello world. Now, to run that program, we can simply click the play button up on the toolbar here, which is actually the run button. That will build the application. Whoops, let's try that again. There we go. That will build the application, and it will enable me to see the output down here in the debugging area, which consists of the left side where you'll do your step-by-step debugging if in fact you want to use breakpoints, for example, and the console output area over here on the right side. So for example, if I go ahead and duplicate this statement and run the program again, it'll rebuild it, and it will then display the output of both statements, in this case producing the same output multiple times. So that's just the basic project, and as we get into multiple source file programs, we will go to our projects folder inside of the project navigator here, which is the area where you see all the files for your project. We'll right-click that folder and say New File so that we can add Swift files to our project. And once we do that, let's just do a sample one for argument's sake here. So once we create the file, whatever name we give it will show up here, and this will be the sample file that's created. Of course, in your case, it'll probably have your name and copyright information based on what you supplied as the company name in the project settings as we created the project initially. So that's the basics of setting up a project. Now, as far as the window that you're looking at is concerned, there are four main areas. This area over on the left side here is called the Navigators area, and the leftmost icon is for the Project Navigator, where you see all the files in your project. Let's go back to main.swift there for a moment. In the middle here, we have the Editors area. On the right side, we have the utilities area, which by default is showing quick help. So for example, if I click in context over here in the source code, it's going to show me information about the item I clicked on. So in this case, it's showing me information about the println function from Swift. And by the way, the angle bracket notation that you see here indicates that this is a generic function. So println is one function that you have access to. It tells you a little bit about that function. And of course, if I were to start dealing with various types that are built into Swift or that are built into various libraries, as I click in a type or a method name, it's going to tell me information about the item I clicked within in the source code editor. Down at the bottom, we have the debug area, and the left, right, and bottom areas are all toggleable on the screen. So if I use these icons in the upper right corner here, I can use this to collapse and expand the three different areas on the user interface that surround the main editor's area. Now, within that editor area, you also have access to, beyond the standard editor, what's known as the assistant editor, which is the same assistant editor, by the way, that I demonstrated to you for playgrounds in the prior video. And then there's separately what's known as the version editor. So if in fact you are maintaining source code for a project that is being revised over and over again, the version editor can be used to help manage the different versions of that project. And for example, if you introduce a bug along the way, you might want to revert back to a prior version. Those are the types of things that you can use the version editor for. Now, as far as the navigators area is concerned here, there are a whole bunch of navigators across the top. The second one here is the symbol navigator. So for example, if you had a class that you were inspecting, this would show you the name of the class and the names of the methods and properties within the class. There's a search navigator that allows you to search through your entire project for specific strings. There is the issue navigator, which you can look at when you get compilation errors. So for example, if I purposely misspell println here, not only do we get a stop sign directly in the IDE in the editor's area, I can also go to the issue navigator and see what the issue is there as well. So use of unresolved identifier printn, and of course it's spelled wrong, so if I go and change that and click outside, it recompiles the code and the issue goes away. The next icon is the so-called test navigator. This is for unit testing purposes. Then we have the debug navigator, which you can use during the debug phase. We also have a breakpoints navigator that enables you to manage the breakpoints throughout your source code. And finally, we have a report navigator that allows you to look at things like log files that are created each time you build and run your app. Over on the right side, the set of tabs that appear across the top of the utilities area is context sensitive. By default, you get the file inspector and the quick help inspector, but for example, if you were developing an iOS app and you were looking at your app's graphical user interface, then you'd have a whole bunch of additional tabs across the top here. For example, for a given button, you could set attributes of that button. So there's something called the attributes inspector, and there's a size inspector that you can use for the purpose of specifying the size of items in your graphical user interfaces, etc. So there are a number of things that are context sensitive, including in the menus across the top of the screen as well, and those are going to depend on the current task you're performing in the IDE.